Hello and welcome to the video tutorial on sequences and geometric progression. Just like the last video on arithmetic progression, in this lesson we are going to understand how we can derive the nth term, the sum of terms and the geometric mean. So without further delay, let us start our today's lesson. The nth term in a geometric progression can be found out by the formula nth term is equal to a into r raised to the power n minus 1, where a is the first term, r is the common ratio between the terms, and n is the term number. Now let us see what geometric progression is. If suppose we have a sequence 5, 25, 125, 625 and so on, what is common between each term is the ratio. That is, if 25 is divided by 5, we get 5. Similarly, if 125 is divided by its previous term, that is 25, we get 5 again. This pattern will remain the same for this sequence, which means that if the first term is equal to a, which is equal to 5, the second will be the first term into the common ratio raised to the power 2 minus 1, which is equal to 5 into 5, which is equal to 25. The third term will be equal to the first term into 5 squared, which is equal to 125. Just like arithmetic progression, in geometric progression, to find a term, the first term is always multiplied by its common ratio raised to the power, which is the term number, the respective term number, minus 1. Hence, the nth term in a geometric progression is equal to a into r raised to the power n minus 1. Let us now solve a problem related to the nth term of a geometric progression. This problem is asking us to find the ninth term of the sequence 6, 36, 216 and so on. We know that the nth term of a geometric progression is equal to a into r raised to the power n minus 1. A is equal to 6 here and r is also equal to 6, because if we divide 36 by 6 we get 6. And if we divide 216 by 36, we get 6 again, which means that the common ratio of this sequence is 6. Putting the values in the equation, we get ninth term equal to 6 into 6 raised to the power 8. And this is our answer. You can calculate it if you want to, but GRE does not ask questions which require lengthy calculations, right? The formula for the sum of the terms of a geometric progression is equal to a into 1 minus r raised to the power n divided by 1 minus r. It can also be written as a into r raised to the power n minus 1 divided by r minus 1. The geometric mean of a sequence is equal to a into b under the root, where a is the first term and b is the last term of that sequence. Suppose we have to find the geometric mean of a, 12, 16 up till 32. We will have a equal to 8 and b equal to 32. And our geometric mean will be equal to 8 into 32 under the root, which will be equal to 16. Kindly remember that if we are given a sequence with fractions involved, just like in this question, the sum of the sequence will be a over 1 minus r. Because in fractions, when you move towards infinity, the value of each term gets closer to 0, which means that the common ratio with fractional power having infinite exponent will give us a value too little to be significant. Therefore, our answer will be equal to a into 1 divided by 1 minus r, which is equal to a divided by 1 minus r. On your test, you may come across a question or two to calculate the sum of more than 100 terms in a sequence, which is quite taxing. But you can save your time by knowing a few formulas to help tackle such problems. So to find the sum of the sequence of 1, 2, 3, 4, 5 up till n, the sum of terms will be equal to n into n plus 1 divided by 2, which is equal to n over 2 into the first term plus the last term, which is exactly the same formula used to find the sum of terms in arithmetic progression. Okay, now if we are to find the sum of a sequence of 1 squared, 2 squared, 3 squared up till n squared, we'll use the formula which is the sum is equal to n into n plus 1 into 2n plus 1 divided by 6. And lastly, if we are to find the sum of numbers with powers of 3, we will apply the formula n into n plus 1 divided by 2 the whole square. Right? This is exactly the same formula which is used to find the sum of terms in a sequence 1, 2, 3, 4 up till n. But we have squared that formula. Right? Let us do a few problems on sum of sequences. Now to find the sum of 1, 2, 3 up till 2500, what we will do is put the value of n, that is 2500, in the formula n into n plus 1 divided by 2. This will be equal to 2500 into 2500 plus 1 divided by 2, and we'll get the answer this way. Okay, coming to the second problem, we have to find the sum of 1 squared, 2 squared, 3 squared up till 500 squared. We will solve it by putting the value of n, which is 500, in the formula n into n plus 1 into 2n plus 1 divided by 6 to get to the answer. Okay, our third problem says that we have to find the sum of 1 cubed, 2 cubed, 3 cubed up till 25 cubed. We have n equal to 25, and so putting the value of 25 in the formula n into n plus 1 divided by 2 the whole squared, we get 325 the whole squared, which is equal to 105,625. With this, we come to the end of our video tutorial on sequences and geometric progression. It is quite an interesting topic, provided you don't confuse yourself and enjoy solving problems related to it. So it's goodbye from me for now. Keep smiling and practicing GRE Quant. Thank you very much.